Hello everyone and be well everywhere you are. At first, I say that English is not my native language, so I apologize if there is any problem with my pronunciation or grammatical points. But I'm sure that I'm gonna transfer whatever is in my head. I would like that this video was the first video on my YouTube channel, because all other videos will be a branch of this video. I think that nobody wasted his or her time like me for numerical simulation due to irrational or unsystematic performance. For example, I was taking my time for numerical setup. I was running the simulation, and when I was checking my results, I saw that they were not consistent with benchmark documents. I was investigating more and more, and eventually I was finding out that I had not enabled an important checkbox. So I was asking myself, I spent my time for what? Nothing. Based on this experience and other experiences, I found out that there must be a way leading to an efficient and correct numerical simulation. So in this video, I want to tell you about it. This is obtained by going deeper into the fundamental concepts. Let's have a look at this procedure. Step 1. At step 1, you must list all parameters that you think are effective in your simulation and any simplification. For example, the gravitational force is important to my simulation, so write it down. The density of the fluid is a function of temperature. List it. The fluid flow is in the laminar regime. This work will prepare your mind to think about different aspects of your problem. Okay? Or my problem is unsteady in nature, but with a good approximation, I can solve it in a steady mode. Step 2. Read documents relevant to your work. For example, CFD textbooks and do a literature review can be so helpful. In this way, not only you learn basic fundamentals, but also you know the software or programming language that is appropriate for your specific problem. Again, you maybe need to modify your list in the previous step, adding new items and also knowing the software that is common in your field. Even you are not an expert uh, in it. Okay, for example, I remember that I wanted to simulate an axial compressor, so creating an appropriate mesh was unavoidable. Although I was expert in ANSYS ICM-CFD, I used ANSYS Turbo Grid because it made it much easier to create a structured mesh type. So I switched to ANSYS Turbo Grid. Step 3. Determine the procedure of your simulation. You can use a Microsoft Excel, a spreadsheet, or any other software. At first, there is no need to write details, just write the overall procedure from start to end. And as you proceed, you can complete it. Note that for every word that you write in this list, you have to have a logical reason. For example, if I ask you about the reason why you chose this boundary condition, you should have sufficient reasons based on reference documents and the physics of the problem. This is one side of the subject. The other side is this. You should give it to any person around you, for example, your friend, and your friend should obtain the same results, the exact same results as you obtained. I mean that the procedure should be explicit with any details that are necessary, such that everyone can do that and reach the same results. This is the reason why imagine 3 or 4 years later you want to run this simulation. Now you have a file with the precise procedure and any details that may be forgotten, but you have all of them in just one file. By these 3 steps, I tend to bring all hidden information and dark points from the back of your brain into the front, such that there will be no dark areas and there will be no doubt in your performance and your numerical simulation.